Saxon's Calculus Lesson 18 is graphs of logarithmic functions and then period of a function. So once again, when we're graphing log functions, we know that we're graphing a curvature, and before we graph the log, we rearrange it to its exponent format to make life simple. So example 1 says y equals log 4 of x, and it wants us to sketch the graph of that. So if I rearrange it, I have 4 as the base to the y, that's the exponent, equals the large number, which is the x. So when I do my xy chart, I realize that what I want to do is pick values for the y instead, get the answer for the x, and then graph them. So I'm going to choose my 0, 1, and -1 for the y half. Anything to the 0 is a 1. 4 to the first power is 4. 4 to the negative first power flips that over and makes it 1/4. Now graphing it, however, I do the graph exactly the way the coordinate point should be. 1, 0, 4, 1, a fourth, -1. So 1 over 0 up, 2, 3, 4 over, that's not spaced very well, 4 over 1 up, and then a fourth over drops me to the -1. So I see my curve happening here and getting larger, and then I realize that I'm getting tighter and tighter. So the y-axis has become functioning as an asymptote. So it's going to bound me there for that curve. Example 2, sketch y equals negative log base, 4, and the big number is the x. So I still want to rearrange. 4 is the base. Oh, and I do have to deal with this multiplying negative, and whenever I have something multiplying in front of a log, remember that it becomes part of the exponent to this one over here, so this is going to make it x to the -1 when I'm rearranging. So 4 to the y equals x to the -1. Now I can't really, I feel like I would be choosing values for y and x, and obviously I can't do that. So I need to make an adjustment so that this is a plain x and make this negative be a part of things that are happening over here. So how do I turn this into a 1 x to the first power? Well, -1 times -1 will give me +1, and if I do that to this side, I need to do that over here. So now that's really -y. So in my xy chart, I now know that I'm still picking numbers for the y. So 4 to the 0 times anything is still 0, so 4 to the 0 is 1. And 1 times -1 is -1, so 4 to the -1 goes back to the fraction 1/4. -1 times -1 is +1, so 4 to the first is 4. Now graphing it in the correct order, 1 over nothing up, a fourth over 1 up, and then 4 over drops to the -1. So my curve, I'm going to be bounded again, very tight fractions with the y-axis, and then it's going to curve bigger here. So it's the same curve, but in essence, I have flip-flopped it over the x-axis. Now, that was example 2. Example 3. If b is greater than 1, oh, and they have to clarify that because all of their a, b, c, and d parts of this equation all have log statements. And can we have negatives with our log statements? Nope. And that's why it clarifies b has to be greater than 1. Then if that's true, then it wants a graph for y equals log b of x, y equals negative log b of x, y equals log b of negative x, and their final one, y equals negative log, knew there had to be another change in there, base b, which I didn't write, of the negative x. Okay, so rearrange our first statement. We're going to have b to the y equals x. Well, that feels an awful lot like what we just did. Oh no, except we had 4s. And this is a, b, anything greater than the 1. All right, I'm basically going to say that this graph here that I did is an acceptable graph, except for the fact that they're going to put b comma 1 wherever they're, yes, because here the base was 4, it yielded 4 gives 1, and I don't know where b actually is, so they just labeled it. So they basically did this curve. Sorry, that was a little crooked. I know that I'm bounded by the asymptote line, and then, okay, so wherever my curve hit 1, they labeled that b comma 1 so that I would know the base was b. All righty. Now, same thing. This time it wants it negated. Okay, so I can't put them on the same ones. So the negative, just like it did, no, I didn't do it. Yes, I did. I did a negative in front, just like that one. We're going to have a curve that's curving this way. And again, I don't know where that b is, so wherever negative 1 would fall, they're going to label that b negative 1. Oh, which they didn't bother to do in this one, but that's okay. And then the third one negates the x. So how does that change the graph? So this one, the original was here, and the negating the x flips it over the y-axis. So before I was flipping it over the x-axis, now it's flipping over the y. So the curve is still bounding to the y-axis, and it's going to do something like so, and wherever my first one is, I would label that, oops, negative b1. Okay, and then for their last one, where they're both negated, you're going to take your last curve, it's still going to be on the negative side of things, and it's going to, instead of going down here to get to the y-axis, I'm tight here at the y-axis, and then wherever that, you know what, they're not even labeling it. You get the idea about where you're labeling your b's. Okay, now shifting gears completely. Example 4 says graph y equals natural log of the absolute value of x. So I know my natural log is dealing with a base of e, but that's still graphing a curve. And the absolute value means I can't have negatives, so that's going to adjust my curve. So if I rearranged it, I'm technically saying the base is e to the y equals the absolute value of x. So I'm picking values again for the y, 0, 1, and negative 1 perhaps. Make sure I shift that. So anything to the 0 is 1. E to the first is approximately 2.7 from that memorized number. And then negative 1 would make it 1 over e, 1 divided by 2.7. That's a decimal of some sort, point something or other. So I would graph 1, 0, 2.7 is almost at the 3, and then up to the 1, and then negative 1 is some tight decimal. So this curve, oh, but it's on the other side. It is a tight decimal, and it's not negative. It would be here. Okay, so here's the thing with the absolute value. I said that I can't have the negatives, and so I'm going to end up being skewed by the y-axis. So my curve is here, and then it mirror images the curve here. And that's what the natural log absolute value of x looks like. Example 5, I don't really have room to do it justice. Sketch the graph of y equals negative log 1/4 x. Okay, so again, base 1/4, exponent y. This negative is going over here with this one and making it x to the negative 1, which I'm then going to have to shift and make that negative 1 and the positive 1. And so now the only difference is the base is a fraction, whereas before they were whole numbers. And so what it does is it makes, instead of being over here at 1, 0, it's now going to be at a 4th 0. So it's just tightening that curve a lot more than it had been before. Example 6, sketch the graph of y equals log base 2 of negative x. 2 to the y equals negative x. Multiply by negative 1 to change it to positive, which means the negative moves over here. So I know it's going to land from the positive side being the curve to the negative side being the curve. The 2 is actually going to shift me out. I feel like the curve's going to come out a little bit more before it gets tighter into the y-axis. Now, part B is period of a function. And this is where they're changing their basic sine curve or cosine curve. Well, it could be any of them, but they're sticking right now with the sines and the cosines. So let me just write the formula for example 1. Example 7, y equals negative 10 plus 4 cosine of 3 theta minus 135. All right, so there's another mild change here that I see that they didn't do in the trig book from before, and that is that they put this 3 inside the parenthesis with the theta, so technically it shouldn't be there. So the first thing I would have to fix is this 3. So let me backtrack before I even do that. So just as a reminder, this first number is the center line being changed to negative 10. The height is now adjusted from 1 to 4. And then there should be this number outside of the parenthesis, which I'll put there, which is adjusting the period. And then I have my theta with a minus some number, and that is my shift in where it starts. So they are putting all of the changes for a sine curve in this formula. Center line, change of height from 1 to 4. This is the period shift, and this is the phase shift of where I actually start. Okay, so let me fix this 3, and then we'll keep going. Pull the 3 out, and it leaves me 3. So 135 divided by 3 is 45 degrees. Okay, now this 3, I'm going to take what I normally did my 4 sections in, which is 360 degrees. And what this is telling me is that I will have 3 full curves by the time I get to 360 degrees. So in how many sections will it take me to do a full complete curve? Well, that would be, and you would take either 360 or 2 pi, depending on what they give you, and divide it by whatever this number is in front of the parenthesis. So that being the case, I know that I will do a full curve in 120 degrees. Now, before I can start graphing any of that, I need to adjust my start. It's given at negative 45, which means I'm beginning at positive 45 degrees. And then I need my 4 sections coming off of that. Center line, negative 10 should be labeled, height, and low point. 4 things below negative 10 is negative 14. 4 things above it would be negative 6. Now my high point and my low point are labeled. 120 degrees is where I need to do 1 full rotation, and it's starting at 45. So it will end at 165. So these originally were 90, 180, 270, 360. I'm trying to adjust. Usually I just start it, draw my 4 lines, and then fix it. So this 165 is going to be ending here. So my 4 sections are falling in between here. Then cosine means I'm starting either at my high point or my low point. This is positive, so I'm starting at my high point of negative 6, and then I want to get a full rotation curve by the time I get over to there. I may not have my spacing quite right, but this is the definite curve that I have here, making all of those adjustments. And then if you continued, you should see, oh, I don't know whether I can do this or not, That would be a second one and a third one by the time I end at 360. Yeah, my spacing is definitely off. But that is all of the examples from lesson 18.